Promise you, I have no idea what I'm doing. No, I laugh at that because I've spent so much time trying and failing over and over again that I feel like I should be an expert by now. Sometimes the best way to learn things is just to make a gigantic mistake repeatedly. That has been teaching this week for me. So yeah, I am there. I now have to re-provide this link because the link that I just gave you was wrong. Why was it wrong? Because I didn't do any of this correctly. So bear with me. Thank you for your patience so far. This has been a learning process the entire time. The link to access this video, it's not going to help you if you're watching this right now, but the link to the accessing this video has just been updated. So now I can watch the past. I feel like I'm watching history now. So that's great. What I'm going to try to do for this class is one of my lectures I'm going to attempt to do with a video of me writing on a whiteboard like I have been doing, and then one of my lectures will involve me streaming my desktop. So I've learned a lot about how to use desktop streaming services and how to create a YouTube channel, which I have never done before this. There are, I think, 2 YouTube videos of me floating around on the internet, and that's the extent of my interaction with YouTube, other than watching videos. I've never been much of a content creator. I've never been much for somebody who creates online information. So I am absolutely the most novice YouTube streamer you've probably ever heard of. So bear with me here. What I wanted to do for this video is give you a little bit of, well, first of all I want to show you I have posted program download information for SolidWorks. If you have a Windows computer, this only works on a Windows computer. Once again, this software only works on the Windows operating system. If you do not have a Windows computer, this will not work for you. But if you do have a Windows computer, the SolidWorks download instructions are located in the program download information on Blackboard. I just posted this today. This is for the SolidWorks student version for years 2019 to 2020. This information works. I have had somebody test this for me, so I know this is adequate. This is the serial number that all of you will be using for this software. If you do not have a Windows computer, if you do not have access to a Windows computer, you won't be able to use SolidWorks. And that's just the sad nature of the beast here. We all have to make some concessions, and the concession that I'm making here is I'm not going to require any of you to actually do SolidWorks. Oh. This webcam is so good of quality, you can hear everything I'm doing, and it is weird. I need to like move it to a place in my office where it can't hear me anymore. Okay. Yeah, just in case you wanted to know, I tested like 4 or 5 different modalities of collecting audio and video, and this is, at this point, what I have come to. I'm using a PS3 PSI camera for my audio. It was the best audio quality I could get for a live stream. I'm looking at getting a capture card and being able to use a high quality video because the webcams that I have right now for video The best one I have is built into my laptop, which I find to be hilarious, because why even buy a webcam if your built-in webcam, which is smaller, is a lot better. So I guess it's not really that funny, but I found it funny. Let me see. Oop. This is the streaming software I'm using. Streamlabs OBS. I am absolutely novice at this too. My hope is that by the end of the semester I'll be so good at streaming videos that I'll like have a little pop-up of me in a corner and be like, oh ho ho, and then it's me and you can watch me as I make facial expressions and like a real YouTuber. This is my SolidWorks 2018. Yes, I'm using last year's version. You will be using an updated version. Any of the files that, thank you, any of the files that I have for my system should be fine working on yours. So if I send you a SolidWorks file, you should be able to download it. The issue is if you are using 2018 to 2019 and if I was using 2019 to 2020. But we don't have that problem. Gotta wait for this to load. So when you pop up SolidWorks, SolidWorks is a suite of products. It's not just simply one thing. When you open up an AutoCAD document, it opens up and you just have, look, your drawing right away. SolidWorks takes a little bit of work. There are 3 different types of files that you can have in SolidWorks. The first type is a part. So if we go to new, okay. I'm going to wait for the new folder to pop up. I have 3 different things that I can select from. A part, basically what you can think of as a part is, let me check and see if, look, it's the YouTubes. Woo! Okay, so everything is working just fine. Just wanted to make sure of that. What a part is you could think of a part as any individual component. This could be gears, this could be the outside of a car, this could be a car door. Parts can really be any individual piece that is completely rigid, all entirely one piece. From a mechanical engineer's perspective or a manufacturing engineer's perspective, a part would be any one individual piece that is manufactured or created. So if like you're building an I-beam or something, you would make the I-beam a part. If you bolt the I-beam onto a plate, then both the I-beam would be a part and the plate would be a part, and bolting them together would form an assembly. Okay, so what an assembly is it's just a bunch of parts put together. Assemblies have some unique functionality in them. If you're using an assembly, one of the nice things that you can do is you can animate parts so that they move. If you have a strong enough computer, which I doubt any of us have, you can actually do simulations of assemblies and be able to see not only how they move, but how stresses propagate through an entirety of a design, that kind of a thing. You can do some pretty complex analyses just within SolidWorks, considering that finite element analysis is an extraordinarily computationally heavy process. I think it's cool that SolidWorks has that kind of functionality, and there are a lot of businesses that actually do use SolidWorks for its finite element analysis capabilities. Now they probably are using SolidWorks on much beefier computers than any of us have, but that's a different story. So what we're going to start out by learning is we're going to learn about how to do a part. As we transition on, we're going to then learn how to do an assembly, and then we're going to finish out on how to do a drawing. So a part is an individual piece. An assembly is a collection of pieces that all individual pieces connected to each other, and a drawing is a professional display. So we use the layout tabs in AutoCAD to create professional displays of our drawings. You could annotate the layout tabs. You put title block on the layout tabs. It looked really, really official, really nice. We will get to drawings, and we will get to how to make a nice official view of what you made in SolidWorks. But we're not going to get there for a little bit. We've got to focus on these two parts first. But we will get there. For those of you who do not have SolidWorks, or who are not planning on doing SolidWorks, you'll really want to pay attention during this video, these series of videos that I will give you later on this semester, because the drawings, the way that the drawings are laid out is going to be how I'm going to expect you to hand sketch your designs for your final project. Oh, and I guess I should speak to that too. I haven't yet updated the syllabus. I've spent most of my time this week trying to get these friggin' live streams to work. Which once again I'm going to check to make sure. That, yay! It's still working. So that's nice. But what I'm going to do for this semester is I'm going to check to make sure that, first of all, we're still delivering content. I'm going to do the modeling learning assignments. Each week I'm also going to post a quiz over some of the content that we covered. And that's it. The quiz will be, I'll post a Google form, and you just fill out a Google form with questions over content that I gave you in the lectures, over SolidWorks, that kind of thing. So just, as long as you're watching the videos, you should be able to fill out those forms. So between the forms and the Google forms with the quizzes, and watching the videos, and then filling out the modeling learning assignments, really the only other homework I'm going to give you is I will give you reading assignments still. Reading assignments will be due every Tuesday. It will just be questions from the book. You'll read the book, post the questions, just like what you have been doing. And then we will also have final project. So those are the 4 different types of assignments that we'll have for the remainder of the class. Those being number 1, modeling learning assignments, number 2, content quizzes, just to check and make sure you're paying attention. Number 3 will be the reading assignments, and then number 4 is your final project. Your final project will replace the final for this class. Again, I'm not going to issue any tests in this class. I've never been a huge fan of tests, and I would prefer that as a part of an engineering design class you actually sit down and design things rather than taking tests over them and being able to tell me information that you memorized. I prefer application. I think application is a higher form of cognition than just rote memorization. But now I'm getting into educational theory, so that's fun. Anyways, if you have any questions, please feel free to, I think I can actually pop out this chat so I can keep this chat on my screen while I do other things. Okay, so got this chat. You want to make any comments, ask any questions, please feel free to respond directly to the chat, and I will respond to them that way. For now, I'm just going to jump back into SolidWorks. We're going to start by creating a part. And I'm going to try to shrink this so that I can see whether or not somebody's interacting with the chat. Oh look! I have them technologies! Okay, I'll be able to see if somebody posts something here now. Nice. So feel free to make comments as you like. So when you start a new part shows up like this. You've got your XYZ coordinates. That's already a big difference from AutoCAD. Here, everything we're going to be doing is 3D modeling. SolidWorks is specifically designed to be able to make 3D parts. Even if you're taking sheet metal, which is inherently a 2D part, you can bend that into a 3D shape in SolidWorks. It's an incredibly powerful software. Some people, if you've used SolidWorks before, you will probably appreciate the fact that we're transitioning into SolidWorks now, because AutoCAD is a gigantic pain in the butt. And if you haven't used SolidWorks before, you're going to find out that AutoCAD is a gigantic pain in the butt. Even if you liked AutoCAD, which I have some fondness for AutoCAD, but even then AutoCAD's a little bit outdated. But the principles of what is present in AutoCAD, it perpetuates here into what now is SolidWorks. And SolidWorks is fairly industry standard. Pretty much everybody knows what SolidWorks is. I will say that there are companies that use programs like CATIA, Pro-E. There are much more advanced forms of 3D modeling than SolidWorks. Those licenses tend to be extraordinarily expensive. I don't have any of them. I would love to get my hands on them. I would have to learn how to use them, but if I ever got the chance to get my hands on those softwares, heck yeah, I would teach you how to use those, because those are professional skills that big companies look for. If you can say you have CATIA or Pro-E on your resume, people turn their heads. It's really only relevant when you're a young engineer, because not a lot of older engineers use CATIA and Pro-E. That's kind of an entry-level engineer and a technician level task. It's not something that a lot of professional engineers do, because they have a lot more important things to do with their time than just do 3D modeling. But having it on your resume still will be a great way to get your foot in the door into a bigger company. So if you do ever get the chance to learn CATIA or Pro-E or some of the more advanced 3D modeling programs above and beyond SolidWorks, I would say take that, find a way to get me involved. That'd be fun. Anyways, so sorry, I go off on tangents a lot. I don't get to see any of you, so I'm just a constant stream of talking. I've been held in isolation and I just can't stop talking now. These words are just blowing up out of me. This is the background for SolidWorks. The first thing that you do in SolidWorks is you sit here and you look at it and you say, well, what do I do? We're going to look over here at the part tree. The part tree is really important because this tells you all of the operations so far that have happened in AutoCAD. Here, this is the front plane, and so if you ever want to look at what the front of a part is, this is the front plane, this is the top plane, this is the right plane. These are inherent properties to every drawing. It also has established the origin. The origin is an XYZ point located right here. You can actually click on it here, and this is located at 0, 0, 0 globally. I want to stop selecting it. Hit escape. The first thing that you do in any SolidWorks part is you go into Sketch and you click Sketch. Now SolidWorks is going to ask you, hey, which plane do you want to draw on? I like drawing the top plane, just thinking I'm drawing top down. This right here is the origin again. So if I click on this, this, and this, they are the same. It's usually a good idea to start drawing from the origin in a drawing. It tells SolidWorks, hey, the XYZ coordinates of this part in space should be located near the origin. When you do copy pasting, it does make that kind of processes easier. It also allows you to fully define and dimension your drawings. In AutoCAD, what we would do is we would say click a line, we would start drawing, maybe we'd start at 0, 0. We'd go over here and we'd say I want this to be 15 meters long, and I want this to be 10 meters tall, or some dimension. What we're going to do in SolidWorks, instead of focusing on the dimensions, I'm just going to start drawing stuff. So I'm going to say, okay, let's say I'm going to make a an angled bracket for mounting oh, I don't know. Maybe I'm making an angled bracket for mounting a shelf on the wall. Okay? And so this is the best I can do because I'm absolutely novice at this, apparently. By the way, having a mouse with AutoCAD was really helpful. Having a mouse with SolidWorks was also really helpful. If you scroll your mouse wheel, it zooms in and out. If you click on your mouse wheel and move, it actually does a 3D rotate. So the pan feature in AutoCAD, which is one of my favorite features, is now been replaced by a 3D rotate. Not a huge fan of 3D rotate because it always messes up your origins, and then it's like, okay, how do I draw on this? Well, now I've been drawing on the XZ axis. If I click on the Y axis, it'll zoom right back into this. I can click on the Y axis again and it'll flip it around, so I'm looking on the back side of it. But if you ever do click the center wheel of your mouse, get lost, just go over here, click on your Y axis. You can also, there's also some controls for views, ports, which I am not as familiar with, so I'm not going to pretend I know them. But let's say you've got a drawing now. All I did was I drew lines. The important thing that we're looking at next is each of these lines has an individual property. So if I click on this line isn't just 2 points. In AutoCAD, every line also has a property, has a line width, has a layer type. In SolidWorks, clicking on a line, it usually brings up these line properties, which are a lot different. Every line has a relation. Now what the relation means is, okay, here a line is coded by it is being consisting of this point and this point with properties associated with it. So here it's got a vertical relation. What that means is that this line, no matter what I do to this line will always be up and down. It will always travel in the Z direction. It's not ever going to be slightly horizontal, nothing. I can make it for construction, which means it's not a real line. I can make it infinite length. Here's the current line length of it. Here's the current angle. It starts up here and goes down, so it's going at 270 degrees. You can pop up additional parameters, which is where is the X and Y endpoints of this line, what is the change in X, what is the change in Y. You can get all of these properties, and this is properties that a line in AutoCAD would have. But the key difference here is this vertical relation. In AutoCAD, we didn't have a way to force this line to be vertical. So what I'm doing now is I'm just clicking on this line and dragging it. As I drag this line will always be vertical. If I were to click on this line, go into relationship, and hit delete, removing that relationship, now this line doesn't always have to be vertical. I can grab a point and move it around, and now this line, well, now it's not vertical anymore. If I force it to be vertical again, then even if I move this point, it will force that line to continue to be vertical. Same thing goes with this line down here. This line has a horizontal constraint. Now because I drew all of these lines so that they were in a row, every one of these endpoints are connecting. So if I just quickly grab, drag, delete everything, start over again, and draw lines where I say, okay, here's one line, here's another line, here's another line, and here's another line. Okay, now these lines all together really mean nothing, but with relations I can force this to become a rectangle or even a square. So this is just kind of an exercise in adding relations to something. Normally what you would do to draw a square is you just go up here and you draw a corner rectangle, draw a square. Or you could even do it with lines if you don't feel as comfortable with using, an easy tool. But with having 4 lines right here, I can force this to be a square. And what I'm going to do is I'm just going to add relations. For this one, I want this line to be vertical. For this one, I want this line to be horizontal. For this one, I want this line to be vertical. And for this line, well, it's already horizontal. So there's no issues there. Now I've got 4 lines that are all nice. I'm going to click on the points. Every point has existing relationships too. And if I click on 2 different points, you'll notice neither of these points have any relationships. You can fix them. I would never advise hitting the fix button. Fix button causes a lot of issues. It's basically like your sketch thinks that you cannot do anything to move that line. It can really mess with you. Don't hit fix. Fix is a bad method. You only use it if you absolutely have to use it. And you have to be a pretty advanced SolidWorks user to know when you need to use it. For most of you, if you've never used SolidWorks before, please do not hit the fix button. It hurts you, and it makes it so hard to do any kind of troubleshooting if something goes wrong with your SolidWorks drawing. So what I'm going to do now is I'm going to say, I'm going to click on the drop-down arrow on Display Relations. This is in the Sketch tab, and I'm going to hit Add Relation. Okay, the first thing it's going to ask me over here in the Add Relations box is to select an entity. When I hover my cursor over this point, the point turns orange. I'm going to go ahead and click the point. You'll see it shows up as a point. So I clicked one point. I'm going to click this point. Now this one also shows up as a point. What I'm going to do is I'm going to click the merge button. What a merge button does is it turns 2 entities into one. It's going to take these 2 points and converge them so that now they're only 1 point. See, and now it moves the line down so that those 2 points are together. I'm going to hit yes, drop out of this. Now whatever I do to grab this, drag this, whatever I do, I cannot break those points apart because I have established that relationship where this line ends where this line ends. Both of these lines end in the same location. So what I'll just do now is I'll continue to add relations between this point and this point. Now you have 2 points. I will merge them, hit yes, add relation, this point and this point. I've got 3 points here. I still have this one selected. I just clicked on it again and it went away. I click on this one again and it'll go away. Yee! If that's the case, I would just hit escape a lot if you have multiple things selected. Otherwise SolidWorks will complain because you're trying to constrain too many things together. So you got to make sure that when you before you hit the OK button or before you even hit merge, check to make sure your selected entities are correct. Now I've got these 2. I want to merge them. Brings that line up. Yay! Now I'm going to do the last one. Add relation. Pick this point. Pick this point. I've got 3 points in there again. I'll hit escape a lot. Try again. Add relation. This point. This point. Merge. Yes. Now this is great. How big is this rectangle? Well, if I pick this point and I stretch it, I can move this wherever I want. This point right here is on the origin, so I won't actually be able to move that. And I can't move this line, and I can't actually move this line. Clicking on that line and dragging it doesn't do anything. Clicking on this line and dragging it will cause it to extend upward. Clicking on this line and extending it will cause it to go this way. Well, this isn't a square. How do I ensure that this is a square? What we're going to do is we're just going to add another relation. Now here, so far we've just been picking points and adding relations to them. Now I'm actually going to pick lines. So I've got this line selected. I can deselect it. I've got no line selected now. I'll pick this line. I'm going to pick this line. I'm going to pick this line. And I'm going to pick this line. There's a lot of different options that appear for your lines when you want to add constraints. You can make them parallel. I don't want to make all 4 of these parallel because some of them are vertical and some of them are horizontal. That will cause that will cause SolidWorks to blow up. Hey, this line is going to be parallel to a perpendicular line. That's bad. No, I don't want to do that. I can make them all vertical. I can make them all horizontal. Collinear means that all of the lines line up with each other. So like if I'm drawing a line here and I'm drawing a line way over here and I want both of these lines to be in line with each other, you pick the collinear relationship, and then it'll be like it's one line that's just broken in the middle. But the one that we're going to be focusing on is this one down here that says equal. If I click equal, what that does is that says the line length for each of these lines is going to be identical. So all four of those lines are equal. I'll go ahead and say yes to the relationship, and now I have a square. If I grab this and drag it, you'll notice my square gets bigger the whole way. If I grab this line and drag it, it gets bigger or shrinks, but it always stays a square. We've constrained this shape to be entirely one square. But I still haven't put any dimensions on this. Okay? The beauty of SolidWorks is that you can arrange and move your lines and change your dimensions and change your relationships after you draw something. Whereas in AutoCAD, you have fixed locations of points. In SolidWorks, you don't anymore. You have fixed relationships that you're creating. So these fixed relationships, they're going to stay true. This will always be a square. I have forced this shape to be a square. What I'll do to size the square is I'm going to go up here in the Sketch tab and click on Smart Dimension. Smart Dimension is just like the Dimension tool in AutoCAD, except for these dimensions are actually editable. So if I click on a line, it'll say, okay, this line is 6.79. Well, I want this to be 8. And as soon as I edit that, now this line is 8. As soon as this line is 8, this line is also 8. This line is also 8. This line is also 8. You'll also notice that as I clicked on this, and as I put this in, let me delete this out real quick, these two lines are blue. When I put on the Smart Dimension, and I force this to be 8 inches, these lines turn black. There's a big difference in SolidWorks between a blue line and a black line. In a sketch, let me drop out of Smart Dimension so it's no longer going to function. In a sketch, a black line indicates that it is fully defined. All of the relations, all of the dimensions of this line, the point locations are not, I can't add another dimension and change the way this looks. This is fully defined. There is only one way of making this shape with all of these relations, with this size. There's only one way. And a fully defined, fully constrained drawing will turn black like this. It will be really nice. You know exactly what each dimension is. We talked earlier about making sure that your dimensions are very precise, are very adequate for filling out an object. This is very critical at this point, especially in SolidWorks. In AutoCAD, you can miss a dimension, and then what it means is that whoever's reading the drawing will have difficulty reading it. In SolidWorks, if you miss a dimension, it means you're going to be able to edit your drawing. You can click on this line, move it around. You can click on this point, move it around. You can edit your drawing. There's more than one way of creating what you have drawn. And that poses an issue, because then whoever goes to recreate what you're doing is unable to do so. So having a fully defined drawing, in my personal opinion, my professional opinion, Grace just says my audio went weird and echoey. I am sorry. I hope that has resolved. My hardware has not moved. But if that hasn't resolved, then it's going to make live streaming a lot more fun. Anyways, this in a well-defined drawing will have as few dimensions as possible. Okay? What I could do for this drawing is, let's say I go back and I'm going to click on the relationships and I'm just going to delete them. I'm going to delete all of them. Okay? If I delete all of these, then I can click on this point and make this shape be whatever I want. this is still an 8-inch spline. This no longer looks like a square. Now I can force this to be a square by drawing this very similar and saying, okay, in order for this to be a square, this has to be 8, and then this has to be 8, and this has to be 8, and this has to be 8. Oh my! And then I have this has to be 8. Oh no! Now it's a rhombus. And then I'm going to say the angle between these two lines is 90 degrees. Okay, so I can create a square using dimensions. That is entirely possible. But now let's say I don't want an 8-inch square. I want a 12-inch square. In order for me to change this to a 12-inch square, well, I've already got 90 degrees. That one stays the same. I'm just going to delete you because you're unnecessary. Oh, no, apparently that was necessary. Okay. Oh my, it's still entirely blue. Ah, I can rotate. Ooh. It does something funky. Look at that. This is not a well-constrained sketch. Yeah, this is why relations are just so much better than dimensions. You can tell I've been in quarantine for too long because this is not supposed to be this funny. Well, I'm sorry that it has not resolved. I will watch the video afterwards and try to fix the audio, whatever is causing the issue. It may just be that I need an update or something. Okay, well this I think is a good place to stop anyways. I'm going to be giving you some SolidWorks videos and quizzes to take. I still haven't posted the links on Blackboard, but I'm going to do it at the end of this video. I will expect these will be under the modeling learning assignments. So with the modeling learning assignments, if you take the quizzes, submit the quizzes to me the same way that we have been doing it through AutoCAD, or if need be, I may even create a Google form so that they just go directly to me. But I will put the links to those quizzes on Blackboard and a little bit better of an explanation on how to submit them. But that will cover a lot more of the SolidWorks basics. You'll get some SolidWorks information from somebody else who is not me. I like using external videos because in my mind, it encourages people to go out and watch other videos, learn how other people are doing things. The world has solved a bunch of problems before, and it's helpful to learn from the people around us who already know how to solve those problems. We'll go ahead and next week we'll cover a little bit more into SolidWorks part making. You will have probably seen videos on this by that point, because I've just covered the very basics of SolidWorks sketching. At this point I hit exit sketch and we extrude this, turn it into a 3D shape and play around with it. If you have any questions, please feel free to email me. Try to get to my email questions as soon as possible. I have had a million emails in the last 2 weeks, so if I have missed an email from you, I'm sorry. It's not because I hate you. It's because I'm pulling my hair out slowly. This online thing has just been a nightmare. So, good luck to all of you. Again, you'll have a reading assignment and modeling learning assignment due Tuesday night. I will remind you of that in our lecture on Tuesday, and I will probably send out an announcement as soon as I get those documents posted online. Otherwise, enjoy your weekend, and I hope all of you are well.